Hello, this is an additional video regarding the USB-MIDI converter. In this video, I will show you how to emulate an external USB-MIDI keyboard using STM32. In previous videos, we implemented a simple converter that works only for output. We can use virtual instruments to control the LEDs on the board. Now I will show you how to get our board to work in data input mode. I'll show you how to create an external MIDI keyboard shortly. Unfortunately, we don't have keys, so I will use the user button on the nuclear board. Of course, you can use some additional things like this that you can see, but I will use only one user button on the nuclear board. Let's go to our project in CubeMX. Here I have enabled an external interrupt on the user button, which is connected to the PC13 pin. Also, I enabled the PI5 pin to manage the green LED mounted on the board. Then we configure the external interrupt to work with negative and positive edges. And don't forget to enable a global interrupt in NVIC menu for XT line. Let's see to our code. At first, I added some comments for the hint and better understanding what we do. In my code, I added a few things. The main thing is the flag by which the button is pressed. 0 is the reset state, 1 button is pressed, and 2 button is released. For them, I added definitions to the main H file. So key empty is 0, key on is 1, and key off is 2. In the interrupt section, I check what level is on the PC13 pin. If it is low, the button is pressed, then I assign the value 1 to the flag, and if it is high, the button is released, then I assign the value 2. Next, I added a separate function to handle the flag from button click. In this function, I check the reason for setting the flag. If the button was pressed, then I send to USB the data with note on event data that is recorded in tbuffer1. Otherwise, if the button was released, I send the data with note off event that is recorded in tbuffer2. The USB-DLL transmit function is not available by default from main C. For this reason, I need to include some additional header file. The pointer to the USB structure that transmit function is used is also not available, so we added this as external. I added one more little thing. When we press the button, let's make the next node 2 steps apart. To do this, I increment the node code each time the button is released. Since by pressing and releasing the button we work with one node, we must increment both buffers for 2 events respectively. After the node step is achieved the value 58, we reset it to default. As for USB-D audio C file, so we have an audio data in event. I don't do anything in it, I just delete everything except the last line. Briefly, that is all. Let's try to flash our device and then let's see what happens. So, download verified successfully. Let's connect the cable and check the device manager. Device is connected. And we can see MIDI STM32 audio. That means it's all okay. Let's start our virtual piano. In this case, in instrument menu, I selected Microsoft JS Wavetable Synth. And in options menu, I selected MIDI STM32 audio as MIDI input. Now let's try to press the button on Nucleo board and see what happens. To summarize, I have shown you the basics of how to add a USB MIDI interface to the STM32. Of course, the implementation of USB MIDI devices is quite complex. Using descriptors, you can add various options, such as the number of logical cables, assign string names to them, and much more. That's all about MIDI, I think. Further videos will be about something else, perhaps about ESP32 or FPGA development. Thanks for watching.